Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. Like Dr. A said, I am Amy Sink and I am one of the math specialists here at the Learning Liaisons. And I just absolutely love spending Wednesday nights with you doing math. In fact, one of my coworkers today, I was like, I got to get out like at a reasonable hour today. Like I have Wednesday night math night and it's been like a stressful week getting school ready. And he goes, oh, so relaxing going to do math. I was like, actually, it is for me. It's not for everybody else, but like, I love getting to do this. And so, yes, this is relaxing for me, surprisingly. I'm one of the few weirdos in the world. It's fine. I don't mind being weird. So, all that said, I live in Orlando, Florida, and I've been with the Learning Liaisons for about 3-4 years now, and we are just here to help you. So every Wednesday we are here doing math problems together, and this session is for you. So if you're thinking of anything that you need help with, don't hesitate to like comment in the comment box and let us know, because that is why we are here. So I always have like a little notes section that says, you know, what are we going to go over next week? Or let me rephrase that, in the coming weeks, because I don't always get to placing it, but like I always make sure I go over the topics that are requested. So without further ado, let me know in the comment box, where are you from? What test are you prepping for? And my get to know you question this week is going to be, where are you from? What test are you prepping for? And what's your favorite dinner? We haven't done that one. And it's so hard to think of like new questions to ask, but what's your favorite dinner? I'm only asking because I literally just finished my dinner. So what's your favorite dinner? I think like at home dinner. I think mine is probably like my favorite quick dinner is a good quesadilla, like stuffed with chicken and black beans and sauteed onions and peppers and cheese and guacamole, like so Yummy. That's my favorite quick dinner. My favorite like long dinner would probably be, I mean, it's not long, but would probably be Mongolian beef. My husband makes the best Mongolian beef recipe. So that would probably be my favorite like long dinner. So where are you from? What test are you prepping for? Those are the two more important questions. And what's your favorite dinner? And some people love a good like breakfast for dinner. My brain can't do breakfast for dinner. Like I cannot even fathom eating pancakes or waffles or eggs for dinner. It doesn't work in my brain. I don't know why, but it just doesn't. Okay, without further ado, let's go ahead and get started for tonight with our first question. It took a while for my iPad to decide to connect, but here we are. We're ready to go. Here it is. Now, if you have been with me for any amount of time, you know that this iPad, it's amazing, love it, but it disconnects. So if it disconnects, I promise I will reconnect it throughout the night. But let's go ahead and get started with our first problem. Problem number 1, solve for x. 7 minus 2 parentheses, 3x plus 4 end parentheses, all divided by 5x equals 3. So how are we going to solve this problem? This is a classic solving an equation with multiple steps. So if you are K through 6, you need to understand how to solve like 1 and 2 step problems. Everybody else needs to understand how to solve multi-step problems. However, if you are taking a K through 6 exam, even though this is a multi-step problem, knowing what to do in each step is critical. Because I could very easily take this and every step along the way, I could make it a 1-step problem or a 2-step problem. So with that said, make sure you understand how to solve each step. Hi, Tanya. It is good to see you. You are taking secondary math. This problem's perfect for you. In fact, a lot of the problems tonight are going to be perfect for you. And you love Mediterranean. That's amazing. I do not love Mediterranean food, but that's just me. But that's why we're all different, and I love it. Okay, so I'm going to rewrite the problem. 7 minus 2 parentheses, 3x plus 4, close parentheses, divided by 5x equals 3. So what am I going to do first? Whenever I see an equation with a fraction, my goal is to get rid of that fraction to make it all one level. It doesn't mean that I'm scared of the fraction. It just means that I need to simplify it to get that numerator out of numerator jail so that I can finish solving it. So what I'm always thinking when I'm solving a problem that is an equation, I'm trying to think, how do I undo what's being done, right? So how do I undo addition, subtraction? How do I undo multiplication, division? How do I undo an exponent, a square root? And vice versa. How do I undo subtraction, addition, division, multiplication, a square root, square it? So in this case, in order to unlock this numerator, which is in numerator jail, I have to undo this part right here. Well, what is that part? What's being done to the numerator? It's being divided by 5x. And sometimes when you don't know what's being done, sometimes reading it out loud can help you. So if you're like, I don't know what to do, if you read it out loud, 7 minus 2 parentheses, 3x plus 4 close parentheses, divided by 5x, I now realize it's being divided. So I need to multiply both sides by 5x. By multiplying both sides by 5x, this crosses off, and I'm left with my numerator out of numerator jail. 3 times 5 is 15 with the x. Now, I can go ahead and begin to simplify this. Again, this is a multi-step problem, so it's going to require multiple steps. So the first thing I'm going to do is distribute this -2 all the way through. Realize that I said a -2, not just 2. It's not 7 minus 2, and I'm only distributing that 2. It's 7 minus 2, and that minus 2 gets distributed. The number one mistake, well, there's a lot of mistakes people can make in a multi-step problem like this, but one of the biggest mistakes people are going to make in this is they're going to say 7 minus 6x plus 8. And they're not going to realize that that negative distributes all the way through. So negative 2 times positive 4 is negative 8. So 7 minus 6x minus 8 equals 15x. What's my next step going to be? Hey, Susanna, it is good to see you. Math Praxis 7813 spaghetti. Oh, I love spaghetti. Have you ever tried $1 million spaghetti? Drop a comment in the comment box. Have you ever tried $1 million spaghetti? You have to Google it if you've never tried it. It is so delicious. Like, so delicious. All right, moving on. The next step is to combine like terms. So on the left side of my equation, I have a 7 minus 8. Now, I cannot do 7 minus 6x minus 8. I can do 7 minus 8 because the 7 and the 8 do not have variables. Because the negative 6x has a variable, it cannot combine with regular, good old boring terms. So 7 minus 8 is negative 1 minus 6x equals 15x. Problem, I have x's on both sides of my equation. So now I need to move the negative 6x over to join with the 15x. So I'm going to add 6x to both sides. Here's another mistake people make. People will subtract the 6x, cross it off, and subtract the 6x. But if I do negative 6 minus 6, I'm going to land at negative 12, which does not cancel that out for me. So you have to be really careful with paying attention to those signs. I'm going to add 6 to both sides. So I am left with, and I'm going to shrink this down just a little bit so I have room. I'm left with negative 1 equals 21x. And now because the x is being multiplied by the 21, I'm going to divide both sides by 21 because remember, my goal is to get x by itself. Negative 1 divided by 21. So my answer is A. Now, some of you might be going, but Amy, hear me out. I didn't do plus 6x on both sides. I did minus 15x on both sides. And then I moved the positive 1 to the other side. Am I still going to get the same answer? Yes. As long as whatever you do to one side of the equation, you do the exact same thing to the other side of the equation, and you computationally solve it correctly, you will get the same answer as me. It doesn't matter in what order you do it in. I kind of think of math equations like this as like a balance scale. So you know those old school elementary like balance scales, and it has the little triangle here, and it has like the bucket over here and the bucket over here. And let's say you have 8 cubes over here and you have 8 cubes over here, right? And it's balanced. Well, if I add 3 over here, I add 3 over here. If I take 7 out of here, I take 7 out of here. If I multiply this side by 2, I'm going to multiply this side by 2. As long as whatever I'm doing on both sides of the bucket is the same, my equation is going to stay balanced. My balance scale is going to stay balanced, and it's not going to tip on either side, okay? All right, let's move on to problem number 2. At a playground, the ratio of children to adults is 11 to 4. If there are 75 total people at the park, how many children are at the park? If there are a total of 75 people at the park, how many children are at the park? Right? So this is a really interesting question because there's 2 different mentalities of how you could solve this. So I'm going to solve it like the mathematic way, and then we'll solve it just kind of conceptually, okay? what I first want you to realize is if there are 75 total people at the park, which of these answers is absolutely, no matter what, not going to be the correct answer? Which one of those is absolutely 100% not going to be the right answer? 206. So 206 is incorrect. I can't have more children at the park than I have people at the park, right? Like if there's 75 total people, I can't have 206 kids. The other answer that we can kind of get rid of is the 20. Why is 20 absolutely not the right answer? Because there are more children than adults. It says the ratio of children to adults. So this is going to be children and this is going to be adults. And there's more children than adults. In fact, there's way more children than adults. So if I set up a ratio 20 to 75, 55 to 75, or 70 to 75, and these are all children, how many adults are there? Well, 75 minus 20 is 55. So this is 20 children, 55 adults. This is 55 children, 20 adults. This is 70 children and 5 adults. So with that mentality, I can cross off A because I know I need to have more children than adults because of the ratio that they've provided me. So I'm down to a 50-50 shot. And if it was up to me and I was doing a 50-50 shot, I would probably pick B. Why? Because if the ratio is 11 to 4, so for every 11 kids, there's 4 adults. 11 kids, 4 adults. 11 kids, 4 adults. Then I'm probably not going to only have 5 adults at the park if there's 75 people there. So my realistic answer is going to be B. And I didn't really do any math to get there. I just reasoned with the problem. Now, if the answer choices are like 54, 55, 56, 57, or like 52, 55, 58, and 60, then it's a little harder to reason with. And I recognize that. And sometimes that's how the problems are written. So we have to know the mathy way to solve the problem as well. But I just wanted to give you that perspective so that if you're in a crunch or you don't know how to solve the problem, there are ways that you can reason through some of these problems to be able to at least narrow the answer choices down. Let's go ahead and solve it with math though. So children to adults is 11 to 4. And they're telling us that there's 75 total people, and I want to know how many children are at the park. A lot of people are going to do this. 11 over 4 equals x over 75, and they're going to solve it. And they're going to say, it's cross multiplication. That's what we do with ratios. Yes, you're not wrong completely, but that's not the correct ratio. Remember, when we're doing ratios, we have to compare the same thing. So you can't compare children and adults with total. My ratios have to be comparing the same thing. So check this out. I have children over adults being compared with children because they're asking how many children. So that's my X over total. My ratios are not comparing the same thing. So what did they give me? They gave me children, they gave me adults, and they gave me a total. Can I figure out how many adults are in this total? Not quickly to be able to fill in this ratio. They didn't give me that. But what I can do is I can figure out how many total people are in this ratio. So I can do children over total equals children over total. That's what I can do. So that said, if I'm doing children over total, then I have 11 over question mark, we will get there in a minute, equals x over 75. What is the total number of people at the park within that ratio? 11 plus 4. 11 plus 4 is 15. I can go ahead and erase this, and I have 15 right there. So now I can cross multiply because I'm comparing the same things. So 11 times 75, I'm going to use my calculator. Do I have to? So last week I had a couple of people ask me, can you do some no calculator problems? And you know what? I'm actually going to put my calculator aside because this could be a no calculator problem. Here's how. I know how to do, and I'm actually going to flip it, 75 times 11. I can do that. 1 times 5 is 5. 1 times 7 is 7. Placeholder 0. 1 times 5 is 5. 1 times 7 is 7. 5, 12, 8. 825 equals 15x. Look at that. Y'all, you can do this. This is stuff that you already know how to do. So yes, oftentimes I'm solving these problems with my calculator, but sometimes they don't need that, right? Like basic computation I can do with my pen and paper. Mind-blowing because we always have a calculator in our pocket, right? Now I'm going to divide both sides by 15. Here's that one-step equation we were talking about earlier. And x is going to equal 825 divided by 15. 15 can go into 82. 15, 30, 45, 60, 75, 5 times. And I'm going to stop right there. Why? Why am I going to stop right there? Because I am so confident in my ability to divide, and I know 15 is going to go into 82 no more than 5 times. And the only 2 answer choices that I have left after getting rid of the answer choices that just totally didn't make sense are 55 and 70. I don't need to finish this part of the problem because my tens place is going to hold a 5. So I'm not going to waste my time doing extra math that's just not necessary. So my answer is 55. Questions about that? Use your answer choices to help you because it's going to help you save seconds here and seconds there, which is critical time when we're talking about a timed test. All right, problem number 3. Triangle SEL is a right triangle. What is the length of hypotenuse SE? What is the length of hypotenuse SE? This is a very interesting question because so many of you have the base knowledge for this question, but you look at a question like this and you're like, golly, I don't know how to solve this. Golly, I don't know how to solve this. Yes, you do. Let me show you. So, you are so welcome, Lydia. I will continue to keep that in mind. I am so glad that you, and there was someone else too that brought that up, that TExES is no calculators. In fact, I'm just going to kind of write that on my first slide. Next week. But I'm going to make like an asterisk. TExES is no calc. All right, and I wrote TA. I promise I know how to spell TExES. However, that's how they spell their like exams is with an E. Okay. Triangle SEL is a right triangle. What is the length? Y'all, you know how to do this. How do you find the missing side of a triangle when it's a right triangle? How do you do it? Pythagorean theorem. A squared plus B squared equals C squared. That's it. So if we're trying to find the length of hypotenuse SE, and we only have one variable, which is x, then I can literally do a squared plus b squared equals c squared. Let's do it. A squared is one leg, b squared is one leg, and c squared is your hypotenuse. So a squared plus b squared equals c squared. Okay? So now I'm going to do 2x plus 10 squared. Do not make the mistake of distributing your exponent. Do not make the mistake of distributing your exponent. Exponents cannot be distributed. Think about the core value of what an exponent represents. An exponent represents doing that quantity twice or three times or however many times that exponent represents. So if it's squared or to the second power, then I'm going to multiply that thing times itself 2 times. If it's to the third power, I'm going to do that thing times that thing times that thing. So if this is 2x plus 10 squared, I need to do 2x plus 10 times 2x plus 10 plus x squared equals 3x plus 4 times 3x plus 4. Now I can distribute. And someone last week had asked for specific factoring practice. Here it is. I did it last week, but here's another example. We're like unfactoring. So we're multiplying through. Some people use the FOIL method, first, outer, inner, last. So firsts, outers, inners, and lasts. But you know what I like to do? I just like to think of it as one big distributive problem. That's it. I like to take the 2x. Whoops, that's an eraser. I like to take the 2x and I like to distribute it. And then I like to take the 10x and I like to distribute it. So 2x times 2 is 4x squared. 2x times 10 is 20x. 10 times 2x is 20x. And 10 times 10 is 100. Plus x squared equals, I'm going to do the same process with the 3x plus 4s. So 3x times 3x, 3x times 4. 4 times 3x, 4 times 4. So 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is 12x. 4 times 4 is 16. Woo! That's a long problem, y'all. Now, I need to combine like terms. I need to combine like terms. So my x squareds can be combined. I'm not going to do 4x squared plus x squared plus 9 squared because there's this equal sign in the middle and I don't want that to get lost. So 4x plus x squared is 5x squared. 20x plus 20x is 40x. And there's nothing to combine with the 100. It's just a 100. Equals, there's nothing to combine with the 9x squared, so it's just 9x squared. 12x plus 12x is 24x. Plus 16. Y'all, I am not using a calculator. I have not used this calculator yet. Keep that in mind. All right, now I've combined everything that's like terms. But now I need to get everything to one side. And you're thinking to yourself, Amy, whoa, In the first problem we did tonight, you wanted to get the x's on one side and the non-x's on one side. Why are you now moving everything to one side? Because I can already see that this is a quadratic. And because this is a quadratic, it means that I'm going to have to factor it. And that just kind of comes with time. And if you don't know that and you're taking a secondary math exam, you need to know that. So with that said, I know that I'm going to have to factor this out because I can't have, like, I can't put my constant on one side and my x squared and my x on the other and accurately get an answer. So I'm going to move all of this over. Now, again, you could move the other stuff over and that would be fine. I don't like my x squared to be negative. And so that's why I'm moving the left side to the right rather than the right side to the left. It's just a preference thing. So all of this crosses off, and this is minus 5x squared minus 40x minus 100. And this is a 16. So 0 equals 9 minus 5 is 4x squared. 24 minus 40. I like to do it this way. And then make it negative. So negative 16x. And 16 minus 100. Negative 84. Again, I'm purposefully not using my calculator because there are teachers in this room who don't get to use a calculator. However, if you have a calculator, use it. So now I can factor it. Now, I don't love to factor when I have a coefficient right here. So I always try to divide it out if I can. If I can't, then I live with it and I deal with it. But in this case, I can. I'm going to divide everything by 4. So 0 equals x squared minus 4x minus 84 divided by 4, 21. Now I can factor it. So 0 equals parentheses x and x, because x times x is x squared. 7 times 3 is 21, or 1 times 21. But those are the only factors of 21 that multiply to give us 21. And in order to add to get a negative 4, I'm going to do a negative 7 and a positive 3. If you are completely lost on what I just did and factoring is part of your exam, please let me know in the comments so I can slow that down for you. X plus 3 equals 0 and x minus 7 equals 0. So x equals negative 3 or x equals positive 7. Now, which answer is the only viable answer? Not the negative 3. Now, don't get me wrong. We just did all of that work to not even have our answer yet, because it asked us what is the length of the hypotenuse, which is what is the length of this, which means I have to take my x and plug it back in. However, that x also represents this right here and this right here. And this right here cannot be a negative number. This x cannot be a negative number. I can't have a negative length. So that said, I'm going to discount the x minus 3 already. And now I can take the 7 and plug it in to 3x plus 4. So 3 times 7 plus 4, 21 plus 4 equals 25. The answer is A. They threw 7 in there to trick you, because you just did all of this work and you got an answer of 7. And so that's a trickster answer. Questions. That was a big problem, y'all. That was a big one, as my little one would say. That's my 2-year-old's favorite phrase. That's a big one. And I feel like that's what I'm thinking right now about this problem. No questions? All right, let's go ahead and move on to the next problem. Which of the following geometric solids has 7 faces, 7 vertices, and 12 edges? 7 faces, 7 vertices, and 12 edges. All right. So before we can just dive into this, we really need to understand the quick difference between a prism and a pyramid. So a prism is a 3D shape with 2 bases, 2 identical bases, and rectangles surrounding it. The number of vertices equals double the amount of vertices of the base. And you'll see why in a minute. So how many vertices does a triangular prism have? A triangular prism has a triangle base. I know, mathematicians are super creative. So if a triangular prism has a triangle base, then it has 3 vertices. So 3 times 2 equals 6. So this shape is going to have 6 vertices. A pentagonal prism has a pentagon base. I know, crazy, which is a 5-sided shape. So 5 times 2 is 10. It's going to have 10 vertices. So neither of those are the correct answer because our shape only has 7 vertices. A pyramid is a 3D shape with 1 base, rectangles closing off that shape, and the vertices equals the base vertices plus 1. The base vertices plus 1. So a hexagonal pyramid is a hexagon base, which has 6 sides or 6 vertices, plus 1 equals 7. A rectangular pyramid has a rectangle base, which is 4 vertices, plus 1 equals 5. So the correct answer is C, and I don't even know what these shapes look like yet. Now let's talk about what these shapes look like. A triangular prism. A triangular prism is going to have triangle bases. These are just the triangles I chose. It could be triangles like this. It doesn't matter what the triangles look like, right? And then each vertice for vertice is going to connect like that. So how many faces does a triangular prism have? It has 2 identical bases. So 1, 2. Plus how many rectangles? Well, it has this rectangle in the front. It has this rectangle in the back. And it has this rectangle on the bottom. So 3 rectangles. Wait a minute. That looks familiar. 3 is the same number of sides a triangle has. So the number of faces is going to equal 2 bases no matter what. A prism always has 2 bases. Plus the number of rectangles matches the number of sides of your base. So 3 plus 2 is 5. A pentagon, and then the vertices is just double because here's you have your vertices here. 1, 2, 3. 1, 2, 3. So let's look at a pentagonal prism. Oh, this is going to be hard to draw. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we connect them up. There's our pentagonal prism. So we have our 2 bases plus 5 rectangles, 1 for each side. So that equals 7 faces, but it does not have 7 vertices because the vertices equals double the base. 3, 4, 5. 1, 2, 3, 4, 5. Let's look at a hexagonal pyramid. The hexagonal pyramid is going to look like 1, 2, 3, 4, 5, 6. And we're going to connect all this out. And you notice that I have my base, and then there's triangles reaching up, connecting all of the base all the way up. And I just realized that I said rectangles, but we don't have rectangles. We have triangles connecting them. We have triangles connecting all the way up. And so I have my base, which is 1, plus how many triangles do I have? I'm going to have the number of triangles that I have sides of my base, because there's a triangle for every side of my base, which is why it's 1 plus the number of sides of my base. And then the vertices is going to be the same thing, because I have all my vertices of my hexagon plus 1 extra at the top. Hopefully this kind of gives you a picture, a broad picture of what these prisms and pyramids look like, but also how the numerical values of their bases and rectangles and triangles and faces and vertices all kind of make sense with the obvious base that they've provided us with. All right, let's go ahead and move on to problem number 5. Which of the following sets of parabolas, when graphed, have the same y-intercept? Which of the following sets of parabolas, when graphed, have the same y-intercept? You think about this problem, and I will be right back. All right, sorry about that. Someone was at my door, and so I had to go answer it because my husband left, and so there was no one to answer the door, and they were just standing there. So, which of the following sets of parabolas, when graphed, have the same y-intercept? So when we're looking at parabolas, we're thinking about those U-shaped shapes in our graphing system, and someone specifically asked for parabolas, and so here we are. So graphing parabolas comes with kind of a list of things that we're looking at. So when we're graphing parabolas, we have like a menu of things that we can do. We can graph the vertex. We can graph the x-intercepts. We can graph the y-intercept. We can graph the axis of symmetry. And there are other things that we could graph, but these are the most basic things that we can graph to give us a quick picture. So when we're looking at this, when graphed have the same y-intercept. Y'all, there's no reason to graph these because we're only looking for the y-intercept. So yes, it says when graphed, but it would take forever to graph 6 parabolas. So we're not going to. We're only going to look for the same y-intercept. What do we know about a y-intercept of any graph? What do we know about a y-intercept of any graph, regardless of whether it's a line or a parabola or a crazy snake? What is a y-intercept? A y-intercept is where the graph crosses the y-axis. And where the graph crosses the y-axis, my x value equals 0. My x value equals 0. So if I plug in 0 for x, 0 for x, 0 plus 0, because 0 times 4 is 0, minus 3. What's my y-intercept? -3. And that's going to be the case for all of these. This is my y-intercept. 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 So out of those, which ones have the same y-intercept? That's it. That's it. All right, let's go to the next one. What is the vertex of the following parabola? What is the vertex of the following parabola? So, vertex, so we just went over y-intercept. We know the y-intercept is 5, right? The vertex can be found, now, if it's in standard form, which this is how you find the vertex. If it's in vertex form, y'all, just look at it and figure out the vertex. Vertex form is a times x minus h squared plus k, and hk is your vertex. But if it's not in vertex form, then I can do negative b over 2a. And that will give me the x part of my vertex. And remember, a vertex is an x comma y. So then I can take that x part and flood it through my equation to find my y. So So I'm going to do negative b over 2a, where a is this, b is this, and c is this. So negative 6 over 2 times a. Negative times a negative is a positive. 6 divided by 6 equals 1. So that is the x part of my vertex. So I can get rid of b and d. Now, the y part of my vertex is going to be take the 1, plug it back in. So 3 times 1 squared minus 6 times 1 plus 5. 3 minus 6 plus 5. 3 minus 6 is -3, plus 5 is 2. So C is the correct answer. Questions about that? Now, I can take that and graph it. So I could take my vertex, which is 1 positive 2, so over 1 up 2, and I could graph that. And then I could graph my y-intercept, which is 0, 5. So 1, 2, 3, 4, 5. And parabolas are symmetrical. So if this is my vertex and this is 1 point over, then I'm going to have another point at 2, 5. And there's my parabola. It ain't hard. It's overwhelming when we don't have the base knowledge, but it's not hard once we start to realize these little nuances that come with these problems. All right, My next problem is a little bit much to finish going over tonight. So I'm going to save that one for next week. What do you want to see me go over in the upcoming weeks? I'm going to stick around and watch for the comments. Let me know what you want to see from me in the upcoming weeks. And I'm going to turn it back over to Dr. A, but I'm going to be watching for those comments. Definitely some no calculator problems for sure, but what else do you want to see? I hope you guys have an amazing week, and I will see you next week. Bye, guys.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.